Okay, this example is another one with the ideal gas law. So the formula we're going to use is PV equals nRT. Now let's go through our problem here and find the important information. We're given a 39 degrees Celsius. That must be a temperature. 105 kPa is the pressure. 25 grams of O2. And they want to know what's the volume. So there are a couple tricks we've got to do here. So let's assign our variables here. So volume is question mark. Pressure is 105 kPa. Temperature is 39 degrees Celsius. Now we don't like Celsius, we want it in Kelvin. So we're going to add 273 to that and we are going to get 312 Kelvin. And for N, do we know N? No, we do not. All we know is we have 25 grams of O2. Now think back to the mole chapter and figure out how do you get rid of grams and change it into moles. You take your 25 grams of O2, put it over 1, and then you're going to have to divide by the molar mass of oxygen, which since there's 2 of them, it happens to be 32. When you do that, you're going to get 0.781 moles of oxygen. And that's what we need to use for N. So now we've got all of the variables we need, so let's plug them in. Remember, we're looking for V. So my formula to plug in for P, let's draw a line here so we can keep this separated. P is 105 kPa times V, because we don't know that. And N is 0.781 moles of O2 times R, which is 8.31 liters kPa over moles Kelvin. And the temperature is 312 kelvins. So how do I solve for V? Because that's what I'm looking for. To do that, I need to divide both sides by 105 kPa. And that cancels out on the left. The kPa's cancel out on the right. The moles cancel with the moles. The Kelvin cancels with the Kelvin. We're left with liters. You divide 0.781 times 8.31. I'm sorry, you don't divide. You multiply 0.781 times 8.31 times 312 and divide that whole thing by 105. And it turns out that the volume of this balloon tends to be 19.3 liters at those conditions. And then we're done.